Welcome to this lecture. We shall be talking about digital inputs and outputs in Arduino. And our practical exercise here today, we shall be blinking an LED on and off, as you can see in that demonstration. And so we shall be able to use digital pins of Arduino to light an LED on and off at particular and specific intervals. So actually, Arduino is intended for physical computing, and thus it has many inputs and output possibilities. Much of the inputs and output is through attaching electronics to the Arduino pins. Of course, we had earlier discussed that Arduino has digital pins and analog pins. So these attachments can be either digital or analog with various voltage levels. And in this class, we majorly focus on digital outputs. And in the next one, we shall be talking about digital inputs. So digital means that there are two states. In electronics, we represent these two states as low and high voltages. Recall that voltage is the difference in electric charge between 2 points. Typically, the Arduino uses 0 volts as ground or low and 5 volts as high. Arduino designates these states as low and high. So it's important to remember that we have two states in digital inputs and outputs. Low, that is 0 volts, and high in 5 volts in Arduino. In some other boards, it could be 3.3 volts. The low and high states can be input and output using the Arduino digital pins. We had earlier said that. So we shall be using this to light an LED and to put it off, that is on and off. So graphically, this is what we have. The transition from 5 volts to 0 ideally should be abrupt, but later when we shall be talking about interfacing a button, we shall see a concept called debouncing, where the transition is not abrupt or precise as it should be ideally, but that is on another level. We shall talk about it later. So this is the graphical representation of digital states. High, that is 5 volts in this case, and 0 volts in that is being low. So this is like high, then low, high, low. That's actually the basics of digital electronics. So in our practical exercise, this is the circuit we shall be developing on our breadboard. So you need a breadboard, you need an Arduino, you need a USB cable for the Arduino, you need an LED of any color, white, red, green, blue, any of the one that you can find. And then we need a resistor, that is a 330 ohms resistor. Remember in our earlier lecture, we had discussed how to interface or configure an LED circuit on a breadboard, and we had determined which value of the resistor we need for this case, and this is 330 ohms. Remember the color coding, that orange and brown, that is 330, that's 330 degrees, ohms rather. So you connect the positive terminal of the LED to the resistor in series, and then connect it to digital pin number 7 of the Arduino. And then we connect the negative terminal of the LED to the ground pin of the Arduino. So that's all for the circuit. And then we now move to the Arduino IDE and then do the programming of this circuit, which we shall be able to implement and see how it works on the board. So here we are in the Arduino IDE. So we have a blank sketch. So we have these two sections that we had earlier discussed. There's the setup function and there's the loop function. Now the setup is where we put our configurations, that is the setup of the pins, we configure which pins we're using as inputs and outputs. Simply what we put here, that is the command that runs once, and most of the time is the configuration. And the loop is where we put our main code, the logic of our program. So normally begin your coding with comments and description of what it's going to do. So you remember how we put our block commands, a block code, a block documentation or comments. So here we want to blink an LED. So the LED is on digital pin 7. And then we want to blink at an interval of 500 milliseconds. So that's just a brief description of what this program is about. Then we come here at the setup. This is now where we declare the pins we want to use. So in Arduino, for you to use a pin as an input or an output, you have to declare it. And so Arduino provides a function that is called pin mode, and this is how we write in the pin mode. So in Arduino, when you are writing a function, it highlights it in a yellow color or in a different color than black. So pin mode, it means it's okay. Normally you begin the commands in small letters and the next word in uppercase. So it's almost like a camel case. And then we write pin mode. We want to select the pin we want to use for our digital output, that is pin number 7. You write number 7, then you put a comma, then we say it's output in uppercase. In this case, you see, if we write in a mistake, it will be in black, meaning that is not correct. So it's output, that's now in blue, and then we close. And in every statement in Arduino, you have to end with a semicolon. That's simply like any C and C++ programming. And then that is the right way of doing it. So we have configured that. So this is to say that configuring so we have configured our LED to be an output. So it's always important to give the LED an initial state so that it begins as either high or low, on or off. So in this case, we want to to write to a digital pin, there is a function in Arduino which is called digital write. So which pin are we configuring? It's pin 7, and we want to have the LED off in the initial state. So we put low. So low means that it's off, that is at 0 volts. So that's the initial state of this pin of the LED also. So in our loop, this is the place where the code will be running continuously. So first thing we want to do is to make the LED on. So to make the LED on, we digital write to pin number 7 where it's connected and make it high. And so because we want to see this happen, we have to delay. To delay in Arduino is just to make the program stop a little bit so that you can see the output. And so we have a function in Arduino that is called delay. And then in the brackets, you write the how long you want the program to delay or to stop. That is for in milliseconds. So if we want it to stop for 500 milliseconds, you write 500, and then you end that statement with a semicolon. And then after that, we make the LED off. So we do the same, we digital write the pin to pin number 7 and make it low. Low means that it will be off, and high means that it will be on. So you see, this is a comment. So Arduino will not be able to execute this line, this part of the line, because it's just a comment. It begins at a double backslash. So what is executed, that it will write a digital high to pin number 7, and then it will delay for 500 milliseconds, and then it will write a low to digital number 7, and then that will be meaning that the LED will be off. So for us to see that it's off, we delay for also another 500 milliseconds. And so once it's coming to the end of this line, also remember to include a semicolon at the end. So after the end of this line, it will go back to the first line in this loop. So it will be executing continuously. So it will make it on, and then for 500 milliseconds, and then make it off for another 500 milliseconds, and repeat the cycle through and through, so that you'll be able to see this sequence and all over again. So to see that our code is correct and is able to be compiled, we come at this button that is almost like a tick, that is to verify. You press. First, we have to save our sketch. So let's say I want to save it as link LED, and then store it on a folder called intro to Arduino. You can select any folder of your choice and then save. Then it's now compiling, and then it's done compiling. So when you look at this place, it's all white, so there's no error. So meaning this our code is correct. So let's introduce an error or a bug to the code to see what happens. So let me remove the last semicolon and then try to verify. You see, it is now bringing this error saying that it expects a semicolon before the last bracket. So you have to include that. So if we now compile, it's okay, very successful. Now remember, we want now to upload this code to our Arduino board. So we come to the tools and confirm that the board selected is Arduino Uno. But if you have any other, you select the ones that you have. It could be Mega, could be Nano, any of these. And then you come to the port that is connected, and then you have it's connected to port number 8, that is the Arduino Uno. And now you come here to this arrow, and then you press upload. Uploading. Yes, it's done uploading. Now we will move to the board and see how it's working. So, but before then, you can choose to change the delay and make it 1 second, that's 1000 milliseconds, and see what happens by changing anything in this code. You can also change the pin to which the LED is connected, and then you use any other pin on the Arduino. So you can make any changes with this code and see what happens.
So the LED is blinking, and as you can see the Arduino, we have connected the 2 pins. We have ground and on digital pin 7, and then pin 7 is connected to a resistor in series with the LED. As we learned earlier, so this is to limit the current that is flowing through the LED, and we are having the LED blinking at 500 milliseconds. So that is the circuit, and it's so simple.